Hello students, welcome to Breedmark Academy. Myself LS Nanda. Now in our previous year question series of JEE Main and JEE Advanced, this is the today's question. This question is based on the concept of composition of functions. It says for x belonging to capital R, x not equal to 0 and not equal to 1, let f0 of x equal to 1 upon 1 minus x and fn plus 1 of x equal to f0 of fn of x, where n can take values 0, 1, 2, 3 and so on. Then the value of f100 of 3 plus f1 of 2 by 3 plus f2 of 3 by 2 is equal to. Now students, we have been given the function f0 of x equal to 1 upon 1 minus x. We also have the relation between fn plus 1 of x and fn of x. So if I put n equal to 0 in this relation, I will get the value of f1 of x equal to f0 of x. Now from here I can write f1 of x equal to f0 of, just put the value of f0 of x inside the bracket, so it becomes f0 of 1 upon 1 minus x. Now students, to get the value of f0 of 1 upon 1 minus x, just replace x by 1 upon 1 minus x in the definition of the function f0 of x. So it becomes 1 upon 1 minus 1 upon 1 minus x. And this becomes 1 minus x divided upon 1 minus x minus 1. Or finally it becomes x minus 1 whole divided upon x. Now similarly we can find the value of f2 of x by putting n equal to 1 in this relation. So it becomes f0 of f1 of x. It further becomes f0 of, now just put the value of f1 of x inside the bracket, it becomes x minus 1 divided upon x. Now students, to get the value of f0 of x minus 1 divided by x, just replace x by x minus 1 divided upon x in the definition of the function f0 of x. So it becomes 1 upon 1 minus x minus 1 whole divided upon x. So further it becomes x upon x minus x plus 1, and finally this is just x. So now we have proved that f2 of x is equal to x. Now students, we move further. Now students, if I find the value of f3 of x by putting n equal to 2 in the given relation, it becomes f0 of f2 of x. Now we know that f2 of x is equal to x, so it becomes f0 of x, which is 1 upon 1 minus x. Now similarly, I can find the value of f4 of x by putting n equal to 3 in the given relation. It becomes f0 of f3 of x, and this is f0 of 1 upon 1 minus x, which is nothing but f1 of x. We have already found its value, and it is x minus 1 whole divided upon x. Now students, similarly we can find the value of f5 of x by putting n equal to 4 in the given relation. It becomes f0 of f4 of x, and this is f0 of x minus 1 whole divided upon x, and this is finally equal to x, or equal to f2 of x. So what do we observe from the above calculations? You can clearly notice that the functions f0 of x, f1 of x and f2 of x are repeating themselves after a fixed gap. So we can easily conclude that all the functions whose subscripts are multiples of 3, they are all equal to 1 upon 1 minus x. For example, f0 of x, f3 of x, f6 of x, and so on. All those functions whose subscripts leave remainder 1 when divided by 3, they are all equal to x minus 1 whole divided upon x. And finally, all those functions whose subscripts leave remainder 2 when divided by 3, they are all equal to x. Fine. Now students, we have to calculate the value of f100 of 3. For that purpose, we need to find the function f100 of x. Now we know that when we divide 100 by 3, the remainder comes out to be 1. So that means f100 of x falls in the second category of the functions. So that means its value is going to be x minus 1 whole divided upon x. So just put x as 3 in the definition of the function. So you will get f100 of 3 equal to 2 upon 3. Right? Now students, we move further. Now students, we have to find the value of f1 of 2 by 3. We know that f1 of x is equal to x minus 1 whole divided upon x. So just put x as 2 by 3 in this expression. So the value of f1 of 2 by 3 comes out to be minus 1 upon 2. We also have to find the value of f2 of 3 by 2. Now we know that f2 of x is equal to x. So the value of f2 of 3 by 2 becomes 3 by 2. Now finally, we have to find the sum of all of these values. So it becomes 2 by 3 minus 1 upon 2 plus 3 upon 2. And this is finally 2 by 3 plus 1 or 5 upon 3. So hence option C is the correct one. Now students, next question I will be posting in tomorrow's video. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.